Hi guys, so in this video I'm gonna discuss about the Albite Anorthite problem which can be done using a stereograph. So let's get started. So the question is given as a plagioclase feldspar from a dolerite dike observed under universal stage has the given following reading. X is given as n is equal to 250 degree, h is equal to 38 degree and z is given as n is equal to 155 degree, h is equal to 10 degree and the compositional plane n is equal to 125 degree and h is equal to 22 degree. First of all, before getting into the solution of this question, we have to take a look upon the table which gives us the different albite and anorthite content of different mineral species given below. Guys, we are solving this problem using a stereograph method. So for this, we should have some requirements or some things are required. First of all, we should need a stereograph. It's mostly equal area stereograph is recommended more than equal angle stereograph. Then we are required to have a tracing sheet. I have already cleared this problem. I'm going to explain it to you. And we should have a Nicklins stereograph. Stereograph in this manner. The south comes here and the north comes here. Here the east and here the west. And the degrees have been marked here. And each small cubes represent a 2 degree and larger one is almost a 10 degree. So we know this is the center part, and also we should need a tracing sheet. So it should be kept like this, in this manner, and a circle should be drawn. Here we should mark the south here, an arrow mark should be given, and the north also a marking should be given. So let's start to solve the problem. You all have wrote down the question. So we know that here a plagioclase feldspars observed contents are marked here. Here the content of X is given as n is equal to 250 degree and h is equal to 38 degree. Here the X is denoted by a symbol that is a round and then a point inside it. So that denotes X, and Z is given as n is equal to 155 degree and h is equal to 10 degree. Here Z is denoted as a triangle. We can see here a triangle and a dot is given that symbolizes Z, and we also have a compositional plane and it is denoted as a square and a point inside it. So first of all, we got to know that X is given as n is equal to 50 degree. So we have to mark X first of all. So here we have south marked with an arrow. So we have to slowly change, like place this arrow mark in the 250 degree. Like we can see here comes the 250 degree. I have placed the arrow mark in the 250 degree, and the next step is that we have to mark 38 degree from east. Here this is the east of the stereograph. From here we have to mark a 38 degree. So for that we have to marking this from here 38 degree. Here we get say 38 degree, so it is marked as X. So we have gotten the value of X or point of X in the stereograph or in the tracing sheet. In the same manner that we have marked the point X, we also have to mark the point Z. It is given as n is equal to 155 degree and h is equal to 10 degree. So we know the arrow mark has to be placed in the position 155 degree. So this is 150 degree and here we get 152, 154 and 155 degree. And then by taking the marking from H, that is h is equal to 10 degree. So we have to take 10 degree from the east of the stereograph. So here we get the point of Z, and we have already taken and measured the point X here. Now the next step is drawing an arc. It is marked as whether these 2 points falls in a single great circle. Great circle is a circle that we have seen in the stereograph. So this is a great circle and this all are great circles. So we have to find in which great circle these 2 points coincides or falls in. So we have to find that position. Yeah, we almost got it. So this is the position, or this is the great circle in which point Z and point X falls. So the next step is, so this is the east-west direction, or the center point falls through this line, and from this point we have to mark a 90 degree, and that 90 degree falls here. So this point is marked as Y and the symbol is given as this, and from this Y we have to measure how much the distance is from this point to the center. So that is given as 32 degree. That I also have to add that we have also finded the compositional plane that is given as this. In the same manner we have found the X and Z points. So coming to our point, we have got this distance as 32 degree. So we have to shift all the points up to 32 degree. So we got this point 32, this point, this is the shifted point of compositional plane, and here we got this shifted point of Z, and this is the shifted point of the point X. So this is shifted to a measurement of 32 degree in a particular manner, and now we have to do the final result, that is finding the anorthite or albite content and finding what is the mineral composition. Take Nicklins stereograph. So this is Nicklins stereograph. So we see here we have many measurements. So this all denotes like the percentage of particular albite or anorthite content. So here starts the anorthite content and all. So here we have the albite content, and this is actually 90 percentage, 60, 70, like 50, 40 percentage. So what we have to do is, here we have the X point. So in this tracing sheet we have a shifted X point. So we have to keep this shifted X point and the X point of this lens stereograph in a position. Yeah, we have kept the X coinciding, and we have to look into the composite plane. It's the combined plane. So come between 15 and 60 degree. That is the orthite content seen as 50 between 15 and 60 degree. So we have to conclude what kind of thing is present in it. So we have to take a look into the table that we have discussed earlier. So while we take a look into the table that I have previously explained, we got to know that while we get this result as the anorthite content between 50 to 60 degree or 70 degree, it mostly falls in the category of labradorite. So it is the present content of labradorite is given as 50 to 60 degree. So now we can conclude that the mineral species that we found from plagioclase felspar, that is present in dolerite dike observed through a universal stage, is labradorite. It is founded by solving the problem using stereo net, that is we got the anorthite content ranging from 50 to 70 degree In the same way, we will get albite content as 50 to 30 degree percentage. So it is labradorite.